Yeah, we're gonna move to Angelo Zinzi, which is a staff technologist as ASI-SSDC, and he's gonna present the Exoplanet, the SSDC web tool for study of exoplanetary system. So I will turn on my camera when you have 2 minutes left, Angelo.
Okay.
And it's all yours.
Okay, thank you. Can you see my screen?
Yes, we can see it.
Okay, thank you. I will shortly introduce the Space Science Data Center, that is the Italian Space Agency office where I work. The main aims of SSDC is to acquire, manage, process, and distribute space mission data with FAIR principles. And in order to do this, we use international standard for long-term archive preservation and also interoperability. In this context, we thought about a tool for exoplanets, and we will see that this tool is more for exosystem. SSDC has a lot of different branches, so that we can be able to support the scientific community in different kinds. For what regard Exoplanet, the tool I will talk now, the idea starts from the fact that we know more than 5,000 exoplanets so far, with more than 3 exoplanetary systems. So that it is time to make a detailed statistical study of these archives, and this cannot be performed without dedicated tools developed expressly for this aim. Therefore, we thought of this tool named Exoplanet, that stands for Exoplanetary Analysis and 3D Tool, that is available at the URL you can find here, and is also accessible by the SSDC homepage, of course. This is the Exoplanet homepage. You can make queries to different archives, different remote archives, in particular from NASA Exoplanet Archive, from exoplanet.eu, and from ExoMercat. Exoplanet is a peculiar tool since, first of all, start a query looking for planets with the required characteristics, and then makes a query that is transparent to the user in order to look for all the planets in the found system. Therefore, we are shifting from the search of exoplanet to the search of exosystem with needed characteristics. This is an example output page, so that we can see the exosystem as a whole, and we can also expand the exosystem with all the planets and all the characteristics of the planet. Of course, this table is downloadable in order to perform further analysis. We also have the possibility of look at the system in a 3D mode, so that we can inspect them visually, and we can also move and navigate over the system, so that we can have a different perspective of this system. The color of the star is computed based on the temperature. The star radius and planet orbits are in scale. Obviously, the planet radius are magnified, and we have, where available, real orbital eccentricities and inclinations, so that in this way we can have an idea of what the system is looking. We updated the tool some months ago. In particular, we passed to Python 3, also to speed up some queries, for example, to ExoMercat, even if this catalog is is yet to be fixed. And we adapted to new protocols because more or less 1 year ago, the NASA Exoplanet catalog changed its query protocol, and so we used the new protocol to query this archive remotely. We already did science with Exoplanet, in particular, because using the tool, it is possible to perform statistical studies on multiple systems with the desired architectures. These are some of the papers published so far, in particular, together with Diego Turrini of the National Institute for Astrophysics. I published a couple of articles, a couple of papers about the dynamical histories of some exosystems, and I participated to the TASSE project that is an Italian-funded project with PI Alessandro Sozzetti of the National Institute of Astrophysics in order to found a pathway to the identification of solar system analogs. Yes, that's all. Thank you for the attention. And I don't know if there is any question or comment. Thank you.
Thank you, Angelo. Very nice talk.